Welcome to another mathematics lesson for this week. I am Sir Michael Beltran, your teacher for another fun learning experience. Have you ever tried looking for something and actually wondered where it's located? Or have you tried playing treasure hunting when you were a kid with your little map? Well, you have to stay tuned because this lesson is just right for you. Before we start, you have to make sure that you have the following: your self-learning module, your pen, and a graphing paper. So, are you ready? Okay, let us start. Our lesson for today is rectangular coordinate system. And for the learning objective, at the end of the lesson, we're expected to illustrate the rectangular coordinate system and its uses. Before we start with our discussion, let us have a quick game. And let us call this one word twist. You'll be given a word which all the letters are jumbled. And for you to guess the right answer, you'll be given 2 or more clues. All you have to do is rearrange the letters for you to satisfy the clues. And you will be given 10 seconds each for you to guess the right answer. Are you ready? Let us begin with the first word. Word number 1. In astronomy, it is defined as an invisible line around which an object rotates or spins. In mathematics, this is a line that crosses another line at right angles to make a graph. And here is the word. The correct answer is axis. Let us proceed with the second word. In biology, it is defined as the birth, existence, or beginning of something. In mathematics, it is the point where the x-axis and y-axis intersect. Here's the word. The correct answer is origin. Let us now proceed with the last word. In literature, it is a term used to describe the events that make up a story. In agriculture, it refers to a designated area set up for planting. And in mathematics, it is associated in placing an ordered pair on a rectangular coordinate system. Here's the word. The correct answer is lot. Were you able to answer all the questions correctly? Great job! Let us now proceed with our discussion. Rectangular coordinate system consists of 2 number lines drawn perpendicular to each other. These lines define a flat surface called a plane, and each point on this plane is associated with an ordered pair of real numbers x, y. The rectangular coordinate system is also called Cartesian plane. It is actually named after the famous French mathematician René Descartes, who developed it in 17th century. And here are some of the real-life uses and applications of rectangular coordinate system. It can be applied in latitude and longitude lines on maps of the Earth. And it can also be used in describing position and location. And also it can be used in locating air transport, as well as it can be applied in our economy. Here is the illustration of a rectangular coordinate system. We will also be discussing all the important elements of a Cartesian plane, including all the important notes that you need to remember. The first one is the horizontal number line, which is called the x-axis. It actually extends indefinitely going to the right, which covers all the positive real numbers. And it also extends indefinitely going to the left, which covers all the negative real numbers for the x-axis. And the second one is the vertical number line, which is called the y-axis. So in this case, it extends indefinitely going upwards, which covers all the positive real numbers for the y-axis. And it also extends indefinitely going downwards, which covers all the negative real numbers for the y-axis. And next part or element of a Cartesian plane is the origin. So this is the central point of the Cartesian plane, and its coordinates is 0, 0. So for the element or for the value of x is 0, and for the value of y, it is also 0. So you have to remember that the coordinates of the origin is 0, 0. Next, for the x-axis, starting from the origin moving to the right, the number increases going to positive infinity. And you have to remember that starting from the origin moving to the left, the number decreases going negative infinity. In the case of x or y-axis, starting from the origin moving upwards, the number increases positive going to positive infinity. On the other hand, starting from the origin moving downwards, the number decreases going negative infinity. The first coordinate is the x-coordinate, and it is also called the abscissa. And the second coordinate or the second value is called y-coordinate, and it is also called the ordinate. We have to remember that the first element or first value to be written first is the x, and the y-coordinate should be written next. Now, we have to remember these notes. This is very important when we're plotting a point or a pair of coordinates or an ordered pair on a Cartesian plane. The x-coordinate tells us how many units to move horizontally. And if the x-coordinate is positive, that means we have to move to the right. And on the other hand, if the x-coordinate is negative, it means that we have to move to the left. You have to remember as well that we have to start with the x-coordinate. And after that, for the y-coordinate, it tells us how many units to move vertically. So we can either go upwards or downwards. For the positive y-coordinate, it means that we have to move upwards. And on the other hand, if the y-coordinate is negative, it means that we have to move downwards. Again, you have to remember in plotting a point, we have to start with the x-coordinate first and then the y-coordinate. Now, let us check if you fully understand what we've just discussed in plotting a point on a Cartesian plane. Let us have some examples. For example number 1, we are asked to plot point A corresponding to the ordered pair 3, 6. Now we have the ordered pair 3, 6, and we know that 3 is the x-coordinate and 6 is the y-coordinate. And in case if a coordinate doesn't have any sign, it is understood to be positive. So in this case, our x-coordinate is positive 3. That means we have to move 3 units to the right. Why is it to the right? Because the sign is positive. Otherwise, we have to move to the left. For the y-coordinate, it is also positive 6 or positive. In this case, it's positive 6. So that means we have to move 6 units upwards. We have to remember that when we're dealing with x coordinate, we only have to move horizontally. It's either to the right or to the left. It only depends on the sign of the coordinate. So if it's positive, we have to go to the right. If it's negative, we have to go to the left. For the y coordinate, we only have to move vertically. It's either going upwards or downwards. So it also depends on the sign. If the y coordinate is positive, we have to move upwards. If it's negative, we have to move downwards. So let us now plot this point. So for point A36, again, we have to move 3 units to the right. Now, plotting the point on a Cartesian plane, we always have to start on the origin, which is 0, 0. So we have to start with the x. So 3, or move 3 units to the right. So starting from the origin, 1, 2, 3. And then we have to move 6 units upwards. So it's 1, 2, 3, 4, 5, and 6. So that is where our point lies. So this is point A, 3, 6. We have to remember as well that in labeling an ordered pair or a point, we have to use the uppercase or the capital letter of the point. Okay? Let us now proceed with our second example. We are asked to plot point B corresponding to the ordered pair negative 3, 6. So in this case, we have a negative sign for the x coordinate. So that means, as I mentioned earlier, since it's negative, we have to move 3 units to the left. On the other hand, for the y coordinate, since it's still positive, we just have to do what we've done a while back in the example number 1. So it's still, we have to move 6 units upwards. Now let us plot this point on a Cartesian plane. So our point is point B, negative 3, 6. Now, starting again from the origin 0, 0, we have to move 3 units to the left. So 1, 2, and 3. And now for the y, we have to move 6 units upwards. 1, 2, 3, 4, 5, and 6. And that is where our point lies. So this is our point B, which is negative 3, 6. Let us now have our third example. So for example number 3, we are asked to plot point C corresponding to the ordered pair 3 and negative 6. So in this case, our y is negative sign. So for the x, which is still positive, so we just have to move 3 units to the right. And for the y, which is negative 6, we now have to move 6 units downwards. Now let us plot this point. So for point C, which is 3, negative 6, again on a Cartesian plane, starting from the origin, which is 0, 0, we have to start with the x first, so we have to move 3 units to the right. So 1, 2, 3. And now we have to move 6 units downwards. So 1, 2, 3, 4, 5, and 6. So that is where our point C lies, which is 3, negative 6. Now let us proceed with our fourth example. So we are asked to plot point D, which corresponds to the ordered pair negative 3, negative 6. So in this case, both of our coordinates are negative signed. So for x, which is negative 3, we know that we have to move 3 units to the left since it's negative 3. And now for the y coordinate, which is y, or which is negative 6, we have to move 6 units downwards since it's negatively signed. Okay? So when we are plotting this point, which is point D, negative 3, negative 6, The same process on a Cartesian plane, we have to start from the point or from the origin, which is 0, 0. For the x, we have to move 3 units to the left since it's negative. So from 0, so 1, 2, 3. And now we have to move 6 units downwards. So 1, 2, 3, 4, 5, and 6. So that is where our point B lies, which is -3 and -6. Now, if you observe with our 4 points A, B, C, and D, even though they have the same value for x, which is 3, and 6 for y, they still fall on different parts of the Cartesian plane. Why is that so? If you notice, the x and the y coordinates have different signs for each point. That is why they fall on different regions or part of the Cartesian plane. So for this point A, it falls on this side, and for point B, it falls on this side, point C on this side, and point D on this side. So the regions that we refer on a Cartesian plane are called quadrants. So we actually have 4 quadrants on a Cartesian plane: the quadrant 1, the quadrant 2, quadrant 3, and quadrant 4. Now, to understand this much better, so this is the Cartesian plane. So for this region, it is quadrant 1. So the coordinates that fall on quadrant 1 has both positive signs. So for the x coordinate, it should be positive, and for the y coordinate, it should also be positive. On the other hand, for quadrant 2, which is on the upper left corner of the Cartesian plane, the coordinates are, for the x, it will be -x, and for the y, it would be +y. And for the lower left region of the Cartesian plane, which is quadrant 3, for the x and y, they are both negatively signed. And for the last region, which is quadrant 4, the x should be positive and the y is negative. Now, going back to our examples, point A, B, C, and D, we know that point A falls in quadrant 1 because x is positive and y is also positive. For point B, the x is negative and the y is positive. That is why it falls in quadrant 2. And for point C, the x is positive and the y is negative. That is why it falls in quadrant 4. And for the last point, which is point D, both x and y are negative. So that is why our point D falls in quadrant 3. Now, there are some instances where an ordered pair does not fall in any of these 4 quadrants. Let us have some examples. For example number 5, we are asked to plot point E corresponding to the ordered pair 0, 4. So in this case, the value for our x coordinate is 0. That means there is no horizontal movement. So the point will not move to the right nor to the left. However, there is still value for y coordinate, which is +4. That means we still have to move it 4 units upwards. Now, how are you going to plot this point on a Cartesian plane? So the same process, starting from the origin, which is 0, 0, or our point E 0, 4, for the x coordinate, there is no horizontal movement. So it will still stay on 0, 0. And for the y coordinate, move 4 units upward. So 1, 2, 3, and 4. So that is where our point E lies, which is 0, 4. Now, the problem is, in which quadrant does point E belongs? So it does not fall on quadrant 1 nor on quadrant 2. So the correct answer is it's on the x or on the y axis. So it does not fall in neither of the four quadrants. Now let us have our last example. For example number 6, we are asked to plot point F corresponding to the ordered pair for 0. So in this case, our y coordinate is 0. So for the 4 or for the x coordinate, which is 4, and it's positive 4, we have to move 4 units to the right. And on the other hand, for the y coordinate, since it's valued as 0, there will be no vertical movement, or there is no movement to upwards or downwards. Now, how are we going to plot this point F on a Cartesian plane? So starting from the origin, which is 0, 0, and our x coordinate is 4, we have to move 4 units to the right. So 1, 2, 3, and 4. And for our y coordinate, which is 0, however, there will be no vertical movement for the y coordinate, so it will still stay on this part of the Cartesian plane. So this is where our point F lies, which is point 4, 0. Now let us check, or let us practice your plotting skills on a Cartesian plane. Let us have this exercise. So we are asked to find the coordinates of the following points and determine the quadrant where each belongs. So here we have a Cartesian plane where there are some points plotted already. So we have 5 points, which are point F, point A, point I, point T, and point H. So we are asked to find the coordinates of the following points, including their quadrants. So let us start with point F. So here is point F. So remember when we are determining the coordinates of a plotted point, we always refer to the point or to the origin, which is 0, 0. So, and we have to start with the x coordinate or the horizontal movement, and after that we refer to the vertical movement or the y coordinate. So starting from the origin, so we count or we move 3 steps or 3 units to the left because we're trying to trace point F. So starting from here, so 1, 2, 3. So we move 3 places to the left or 3 units to the left. And now we have to move 3 units upwards. So 1, 2, 3. So that is why the coordinates of point F is -3 and 3, because we have moved 3 units to the left, so that means it's negative. And for the y, we have moved 3 units upwards. Okay, now let us move to our point A. So for our point A, same process. We have to refer, or we have to start from the point or the origin, which is 0, 0. Now we have to trace, or we have to track point A. So we have to start with the horizontal movement. So that is 1, 2, 3, 4, 5, 6. So we have moved 6 units to the right. So that means it's positive. And now we have to move 1, 2, 3, 4, 5 units downwards. So that means negative for the y coordinate. So that is why our answer is 6 and -5. Okay, now let us move to the next point, which is point I. So here's the point I, and we start from the origin. Now we try to track the point I starting with our horizontal movement. So 1, 2, 3, 4, 4 units to the right. So that means our x should be positive. And for the horizontal or vertical movement, 1, 2, 3, 4. So we have moved 4 units upwards. So that means our y coordinate should also be positive. So our coordinates for point I is 4 and 4. Now, for point T, so here's our point T. So we have to start with our point or with our origin, which is 0, 0. And starting with the horizontal movement, so we're tracking or we're trying to track point T. So 1, 2, 3, 4, 5. So we have moved 5 units to the left. That means our x should be -5. And now for the y, 1, 2, 3. We have moved 3 units downwards. That means our y coordinate should be -3. That is why our answer is -5 and -3. And for our point H, lastly, so it applies here. So it means that we have to start from the origin, which is 0, 0. So starting from the horizontal movement, you have to notice that there will be no horizontal movement because our point is here. So we don't have to move from the right or to the right nor to the left. So that means our x coordinate is 0. However, we have to move 1, 2, 3, and 4 units downwards. So that's why the value of our x or y coordinate is -4. So that means the coordinates for point H is 0, 4. Now let us determine the quadrant for each point. So for point F, since its x coordinate is negative and its y coordinate is positive, that means its quadrant is quadrant 2. And for point A, since its x coordinate is positive and y coordinate is negative, that means it falls under quadrant 4. And for point I, since both of the x and y coordinates are positive, that means the point falls under quadrant 1. And for point T, since both of the coordinates are negative, that means that point belongs to quadrant 3. And lastly, for point H, if you notice, the x coordinate is 0. That means the quadrant or the point does not fall in any of these 4 quadrants. Instead, it falls on the x or the y-axis specifically. Now, we're able to answer the coordinates for each points and the quadrants where they belong. Okay, very good. Now let us now have a quick recap for our lesson for this day. We have learned that a rectangular coordinate system consists of 2 number lines drawn perpendicular to each other. It is also called Cartesian plane. The horizontal line is called the x-axis and the vertical line is called the y-axis. And the point where the x-axis and the y-axis intersect is called the origin. You have to take note as well that the coordinates of the point of or the origin is 0, 0. And a point plotted on a Cartesian plane or a rectangular coordinate system is called an ordered pair in the form of xy. You have to remember that the x comes first and then y. And also when plotting the points, the x-coordinate determines the horizontal distance from the origin and the y-coordinate determines the vertical distance. While the x-coordinate is called the abscissa and the y-coordinate is called the ordinate. Now, we have 4 regions on a Cartesian plane. So we have the quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So the ordered pairs fall on each quadrant depending on their sign. So there are some cases where an ordered pair does not fall in any other quadrants or in any of these 4 quadrants. It depends if they have 0 for the x or 0 for the y coordinate. Now, let us check if we have fully understood the lesson and if you can apply the learnings in this evaluation. So for the first item, What do you call the vertical number line in the Cartesian plane? Is it A, x-axis, B, y-axis, C, quadrant, or D, ordinate? The correct answer is B, y-axis. For item number 2, in which quadrant is point 0 or point 4 and negative 3 located? Is it A, quadrant 1, B, quadrant 2, C, quadrant 3, or D, quadrant 4? The correct answer is D, quadrant 4. Next item. What are the coordinates of origin? Is it A, 0, 0, B, 1, 0, C, 0, 1, or D, 1, 1? The correct answer is very good, letter A, 0, 0. For item number 4, how will you plot negative 3, negative 5 on a Cartesian plane? Is it A, move 3 units to the right and 5 units downwards, B, move 3 units to the left and 5 units upwards, C, move 3 units to the right and 5 units upwards, or D, move 3 units to the left and 5 units downwards? The correct answer is letter D, very good. You have to take note that both the coordinates are negatively signed. So it's negative 3 for x and negative 3 or negative 5 for y. That is why we have moved 3 units to the left and 5 units downwards. And for the last item, in which quadrant does a point belong where there is no vertical movement when plotting it? Is it A1, B2, C on the x-axis, or D on the y-axis? The correct answer is letter C, very good, on the x-axis. So that is our lesson for today, and I hope you have learned a lot and enjoyed at the same time. So see you again for another mathematics learning experience. So thank you for listening and goodbye.